Welcome back to the another video of the quick vlog. In our previous video, we have talked about the different type of set operations, and in this video, we will be talking about different type of joins. Okay, without delaying, let's go to our video topic, and this is our workbench. Before starting that, let's talk about joins. What is join? A join is used to combine rows from two or more tables based on the relation of the column of those tables. And joins are fundamentally for querying data across multiple tables. As you can already guess from its name, join. That means it will join two tables, or it will show, or it is for querying data across different tables by joining them. Okay, there are various type of joins, and in this video we are going to talk about some common joins. There are some specified join that is used for some specific scenario as well, but let's not make our video complicated. That will be covered in our future videos. So let's use some of the common joins in our video, and those joins are inner join, left join, and right join, full join, and cross join. And the right join, left join are also called as left outer join and right outer join, but in simple we can also say left join and right join. Similarly, inner join, or we also can say it as join. These uh, are some of the join types of join we will be using in today's video. Without delaying, let's start our video. Let's use the database, this one, and this source code will be provided in the description. You can visit there and get the link of the GitHub where you will get the source code and try it in your own PC. Okay, I have already created the table called department, and that is with column ID, name, and manager ID. And similarly, these are the four records of the table department, that is engineering department, finance department, human resource department, and marketing department. Similarly, we are going to create another table called employee, and under that employee we have ID, name, DOV, address, department ID, join date, that means the joining date of the employee, and position of the employee. Now let's insert some certain values, and we are going to insert 10 values having their ID, name, and date of birth, address, department ID, join date, and position. Similarly, we are going to create another table called projects, which will be for storing the data of projects which we are going to, which we are currently running. That is with ID, name, budget, date initialize, deadline, and this is the inserted value. And actually, this database is for our own company, the quick blog, and we are creating this for keeping the records of our progress, how much work is going on, and how much work has been completed. So it is a bit relevant and a bit real life project, a real life example. Okay, we are creating. Okay, before that, let's see some of the values have got null here, and that means the deadline is null, which refers that these projects are running projects. That means it will not have any deadlines, or these projects are those projects which will get updates, or which will be up to dated for a long period of time. So there will not be deadline. So these values have null values. These column, deadline column, have null values in in these records or in these projects. Now let's create some other table like allocation. This is the table that will determine which project is allocated for which employee, and which employee is working on which project from what date and when he or she had exited the project. So we have project ID, employee ID, enroll date. That means the employment enrollment day on on this project, and exit date. That means the leaving date. Okay. Similarly, we have again null values in these projects. That means this employee, employee number ID number 5, 6, 7, 8, 1, and 9. These employee have not exited these projects respectively. That means these projects are being currently running, and so these values are null. Now let's use our main or let's dive into our main topic, that is type of joins and the use of joins. If you haven't watched our previous video, then you might be getting confused on these primary keys, reference, and foreign key. What are these, and how to use insert, and how to create tables. You can see our previous videos, uh, which will help you or which will guide you to understand these all the steps in minute details. Now let's jump to our main topic, that is using joins. And first of all, let's use inner join. Okay, you can see only few uh, columns, and those columns are also from different tables. And this is the main purpose of join. It will show or it will build a relation between two different tables and show us or and run query on our desired columns or our desired tables. Okay, inner join basically returns the row with matching values in both tables. That is like this allocation as A and employee as E. We are denoting it as this, and P for projects. And the project has also column called ID, and allocation has also called project ID. These two fields or these two columns are same values. So we are going to match or we are going to set a relation between these two values. So the first condition inner join, that is the first feature of inner join, it will only show the matching values of the both tables. That means ID and ID are getting matched, and it will show the value of these two tables. Similarly to the employee, we are uh, matching or you are inner joining the project from allocation and from employee. Now similarly, let's go to the left join. Inner join is simple. It will only show the value, or it will only show the rows with matched values. Okay, it is now something different. We have null values here. And what is this null values? Okay, left join returns all the record from the left table and the match rows from the right table. That means uh, it will give priority to the left table and show all the records, but it will only show the matching record from the right table. So the main purpose of the left join is to show or to return all the rows from left table and only showing or returning records from the right table which are being matched with this left table. And so that means uh, the project everything which is a digital encyclopedia basically, uh, it is a left record from it is the record from the left table, that is project, and the employee name, that is from the right table. Um, the project everything do not have any employee currently working under, so the value is null. But as per the left join, we should show all the records which are being or which are recorded in the left table. So it will show the unmatched value also, that is everything digital encyclopedia, it do not have matching value in the right table, but it is showing because we have used left join. Similarly, in the case of right join, it is similar, but it will show all the records from the right part, and it will not show records which are not matched from the left part. Like, let's run it. Okay, all the employees are assigned in some kind of project, so it is showing all the projects. But in case this project was not being worked or was not under the Sangita Maharjan, then it won't be shown here. It would be shown as the null value because it is going. to give priority, or it is going to return all the records from the right table, but it won't return the values unless it has matching values with the right table. That's why if this project was not matched with the right table, then it will show null values, as previously we have seen in the left table with the employee. Now let's go into the join, or this is also called as cross join. And in the cross join, it is a rarely used, or we use this kind of join rarely, because it is not practicable for all the scenarios, and it is only for a specific scenario. But let's learn about this. And in this case, you will see that there is no any matching condition, like in our previous join we have used uh, two different columns and set them as matching columns, but in this case we have not used any condition of the matching column. That means it will show all the records having relations with all the records of right table or corresponding. That means uh, the Suresh Sharma, this employee will have relation with all the projects, so it is showing this much values. That means, okay, let's see how much value we have inserted in our table of project. Okay, we have joined project with the employee. So let's check project, that is project allocation, and this is project. Okay, we have 8 records in the project and we have 10 records in the employee. That means it will show 10 into 8, 80 records or 80 results here, because it will cross join all the records with each record of another table. That means the table or the record A, this one will have relation with all the record of this project with 1, 2, 3, 4, 5, 6, 7, 8. So in this results also, you can see Sangita Maharjan, employee Sangita Maharjan, and or Suresh Sharma. Okay, employee Suresh Sharma have relation with 8 projects. 1, 2, 3, 4, 5, 6, 7, 8. Similarly, Asa Thapa has also relation with 8 projects. Similarly, all the records from employee will have relation with each record from project. So cross joining is not commonly used because it will create multiple datas, and that is not the main feature of handling database, because we want less datas or we want non-repeating datas. And here we can see multiple repetition of data which are unwanted, so it is not quite practicable economically also, because it will require a lot of storage to store these, or it will require a lot of performance. These are queries that this will not be stored, but it requires a lot of performance power or a lot of hardware to show this, in comparison to other join, because other join will only show the matching values or the left right values, but it will show all the records, so it will have a much more demand for performance or power. In this case we have only used 10 and 8 records in employee and then after a project, but in some big projects there will might be thousands and millions of records. So in that case, that this join will cause a lot of problem, because it will demand a lot of power to run those millions of records. But in our case there are less records, so it is giving us instantly the record or the result. But in the case of a used data, it might get failed, or it is impracticable basically. So we commonly use cross-join, but it is something we should have concept about. And if you want to understand about the cross-join, let's take an example of student and organization. Suppose organization is giving two kind of allowance to the all the students. That is, one allowance is for their picnic, and another allowance is for their let's say a museum visit. Okay, these two allowances are given to every student. So if we want to calculate the total costing of these allowance, suppose they are giving $100 to each, uh, under each allowance, that means $100 for picnic and $100 for museum, and each student are getting these two allowance compulsorily. So if we want to take, or if we want to calculate the total amount of money denote donated by the organization, that in that scenario we can use cross join, because it will show the relation uh, from table student. Let's suppose student as a table student and budget at the table budget. Okay, it will show all the relation from the student to the budget. That's why there will be easy to calculate the budget in that scenario, or in common scenario. In those scenarios we will use cross join, otherwise we won't use cross join. So I guess this video was informative for you all. Hope to see you in next video, and leave your feedback in our comment section. And for the source code, you can visit our description. There will be link for the GitHub. Thank you and have a great day.